Stage 1. The ordinary star. Somewhere in this galaxy, a star 20 times the mass of our Sun has been burning for 10 million years. At its core, hydrogen fuses into helium every single second, releasing the energy of 1 trillion nuclear bombs. Gravity wants to crush the star inward. Fusion pushes back outward. For millions of years, a perfect balance. This star is so large, if placed where our Sun is, it would swallow Mercury, Venus, Earth, and Mars whole. For 10 million years, the star's nuclear fire has held gravity at bay. But fuel has limits. All of it does. Billions of worlds orbit massive stars like this one, bathed in their light, shaped by their radiation. Hydrogen is running out. The core fills with helium, an ash that cannot burn, not yet. The star expands, swallowing its children. A red supergiant now, 10 times larger than before. The core is iron now. Iron cannot burn. This is the moment the star begins to lose. Silently, the iron core reaches 1.4 solar masses. This is the threshold. Beyond this, nothing can stop what comes next. Stage 2. The collapse. Collapse. The core falls inward at 70,000 kilometers per second. It will be over in half a second. Protons and electrons are squeezed together. They become neutrons. The very structure of matter rewrites itself. The outer core slams into this neutron ball at 1/4 the speed of light and bounces. A shock wave is born. The shock wave is stalling. The collapsing material above is too dense, too heavy. It's losing, almost. Then, the neutrinos arrive. 10 to the 58th power of them. They save the shock wave. They trigger the explosion. The shock wave tears through the star in seconds. The outer layers, all of them, are blown apart. Forever, in this moment, one star dies. The explosion is already brighter than the entire Milky Way galaxy. Inside this explosion, the universe is forging elements that cannot be made anywhere else. The periodic table, completed. The light reaches neighboring star systems. From there, it looks like a new star has appeared, blazing for months. The stellar material expands. It will become a nebula, a cloud of elements scattered across light years of space. What remains at the center, untouched by the greatest explosion in the universe, is this: a neutron star, 20 solar masses, crushed into an object the size of a city. This is the most extreme object in nature. Stage 3, the supernova flash. At peak brightness, this supernova outshines 200 billion stars, the entire galaxy, dimmed by comparison. The shock wave expands at 30,000 kilometers per second, compressing everything it touches, creating new stars. Death triggers birth. The shock wave compresses nearby gas clouds, igniting new stars from the ashes of the old. Every atom of gold on Earth, every gram of platinum, was forged inside a dying star. Exactly like this one. A supernova remnant, a nebula. It will glow for 10,000 years, seeding the next generation of worlds. The neutron star spins. Its radiation beams sweep the cosmos like a lighthouse. This is what we call a pulsar. Pulsar pulses are more precise than atomic clocks. We use them to detect gravitational waves from across the universe. Some pulsars spin 700 times per second, faster than a kitchen blender. Perfectly stable, indefinitely. The surface is a perfect crystal, harder than anything in the universe. A star quake here releases 1 trillion nuclear bombs. It has a magnetic field 1 trillion times stronger than Earth's. What that means, we are about to show you. Stage 4. The neutron star is born. 1 teaspoon of neutron star material weighs 1 billion tons, more than Mount Everest. From a spoon, surface gravity here is 200 billion times stronger than Earth's. Objects fall and hit at 500,000 kilometers per hour. Impact: a single ball bearings collision with a neutron star equals 1,000,000 nuclear warheads. The star doesn't notice. The surface temperature, 1,000,000 degrees Celsius, 6 times hotter than the core of our own sun. Its magnetic field is 1 quadrillion times stronger than Earth's. It would rip atoms apart from the distance of the moon. It fits inside a city the size of Manhattan, but it contains the mass of 1.5 suns. Inside Manhattan, inside, a superfluid more perfect than any in a laboratory. And at the very core, physics we don't yet understand. This is a magnetar, the most magnetic object in the universe, strong enough to rip electrons off atoms from 1,000 kilometers away. A magnetar flare lasts 1/5 of a second. In that time, it releases more energy than our sun does. Time itself runs slower near the surface. 1 second at the neutron star is several seconds in open space. Einstein was right. Light itself bends under this gravity. Some photons orbit the star permanently, trapped in circles forever, unable to escape. Stage 5, extreme physics. 2 neutron stars locked in a death spiral, separated by less than the distance from New York to Los Angeles. Every orbit, they lose energy and spiral tighter inward. Merger is seconds away. The tidal forces are shredding both stars. Nothing in the universe can stop what comes next. The kilonova. The merger creates a flash seen across 1 billion light years and forges more gold than 1,000 suns could hold. The gold in your ring, the platinum in your phone, all of it, born in a collision exactly like this one, billions of years ago. When it's over, a black hole. In 2017, we detected a neutron star merger 130 million light years away, in gravity and light simultaneously. A new era began, the most massive neutron star known, 2.35 solar masses. The slightest addition, it collapses into a black hole. The line is that thin, theory predicts something even denser. Quark stars, where even neutrons dissolve into free quarks. We haven't confirmed one yet, and is still going. If you could visit, standing on an asteroid near a neutron star, you'd see the most extreme neighborhood in all the cosmos. Now, your question: if a neutron star appeared where our sun is right now, how many seconds before Earth is completely destroyed? Drop your answer in the comments. Neutron stars, the last heartbeat of a dying star and the birthplace of everything you've ever touched, everything you are.